Imagine you're looking at a map of the universe. Galaxies everywhere, scattered like cities of light across the cosmic landscape. But then you notice something that shouldn't exist. A void, not just empty space between galaxies, but a region so impossibly vast that if you traveled at the speed of light for 330 million years, you'd still be inside absolute nothingness. This is the boat's void, and what scientists discovered inside it has fundamentally challenged everything we thought we knew about how the universe works. Here's what makes this terrifying. In a typical region of space this size, you'd expect to find roughly 2,000 galaxies. The boat's void contains only 60. That's a 97% deficit of matter. It's as if someone reached into the fabric of reality and scooped out the contents, leaving behind a cosmic wound that defies the laws of physics as we understand them. But here's where it gets disturbing. Recent observations have found something inside this void that shouldn't be there. Something that's making astrophysicists question whether we understand gravity, dark matter, or the fundamental structure of space-time itself. What's inside isn't just strange, it's rewriting our understanding of cosmic evolution. Before we dive into this mystery that's keeping scientists awake at night, do me a favor. Hit that like button and subscribe, because what you're about to learn will change how you see the night sky forever. And drop a comment telling me what country you're watching from and what time it is where you are. I want to know how far across this planet our cosmic curiosity reaches while we explore the largest mystery in the observable universe. Let's go back to 1981. Robert Kirshner, Augustus Oemler Jr., and Paul Schechter were conducting what seemed like routine galaxy surveys at the Harvard-Smithsonian Center for Astrophysics. They were measuring redshifts, which tell us how fast galaxies are moving away from us, and therefore how far away they are. It's painstaking work, cataloging galaxy after galaxy, building a three-dimensional map of our cosmic neighborhood. Then they noticed something impossible. As they plotted their data, a massive gap appeared in their maps. At first, they thought it was an error. Maybe their instruments were malfunctioning. Maybe they'd made a calculation mistake. But as they gathered more data, the void refused to disappear. It grew larger and more defined with every observation. Think of it like this. Imagine you're making a map of all the cities on Earth from satellite photos. You're documenting New York, Tokyo, London, systematically covering the globe. Then suddenly, you find a circular region the size of Australia, where there are almost no cities at all. Not because it's ocean, but because cities that should be there simply aren't. That's what Kirshner and his team were seeing on a cosmic scale. The boat's void, named after its location in the boat's constellation, measures approximately 330 million light-years in diameter. To put that in perspective, our entire Milky Way galaxy is only about 100,000 light-years across. You could fit over 3,000 Milky Way galaxies side by side across this empty region. The void represents roughly 0.27% of the diameter of the observable universe. It's not just big, it's incomprehensibly vast. Now here's where the foundation starts cracking. According to our standard model of cosmology, the universe shouldn't be able to create voids this large. After the Big Bang, matter was distributed relatively evenly throughout space, with only tiny quantum fluctuations creating slight variations in density. Over billions of years, gravity pulled matter together into the cosmic web we see today, galaxies clustering along filaments with voids between them. But this process has limits. The universe is only 13.8 billion years old. Gravity can only work so fast. The mathematics tell us that structures larger than about 1.2 billion light years shouldn't have had time to form yet. The boat's void violates this limit. It's too big, too empty, and too well-defined to have formed through normal gravitational processes in the time available. It's like finding a 1,000-year-old tree in a forest that's only been growing for 100 years. The math doesn't work. But what really disturbed scientists was the distribution pattern. The 60 galaxies that do exist inside the void aren't randomly scattered. They're arranged in ways that suggest something actively cleared out the surrounding space. Gregory Aldering conducted follow-up studies in 1988 and found that the few galaxies present showed unusual properties. They were younger, smaller, and had different chemical compositions than galaxies in normal cosmic regions. To understand why the boat's void is so disturbing, you need to understand the cosmic web. This is the large-scale structure of the universe, and it's one of the most beautiful and mysterious patterns in nature. Imagine a three-dimensional spider's web, but instead of silk, the strands are made of galaxies. These filaments stretch across hundreds of millions of light years, connecting massive galaxy clusters at their intersections. Between these filaments are voids, regions of relative emptiness. This structure emerged from the tiny density fluctuations in the early universe, amplified by gravity over billions of years. Here's the mind-blowing part. This pattern, this cosmic web, contains more information about the fundamental nature of reality than almost anything else we can observe. The precise spacing of the filaments, the size distribution of the voids, the clustering patterns of galaxies, these all encode information about dark matter, dark energy, the initial conditions of the Big Bang, and potentially the shape of space-time itself. J. Richard Gott III and his colleagues at Princeton demonstrated in the 1980s that the cosmic web acts like a fossil record of the early universe. Just like paleontologists study fossilized bones to understand ancient life, cosmologists study the cosmic web to understand the universe's infancy. Every detail matters. Every deviation from expectations tells us something profound. Normal voids in the cosmic web range from about 30 to 150 million light-years across. They form naturally as gravity pulls matter toward the denser regions, leaving less dense areas behind. Think of it like soap bubbles. When you blow bubbles in a sink, they cluster together with thin films between them and empty air inside each bubble. The cosmic web works similarly, with galaxies forming the films and voids representing the empty interiors. But the boat's void is different. It's not just larger than normal voids, it's fundamentally different in character. Normal voids still contain some galaxies and have matter flowing through them. The boat's void is what scientists call a supervoid, and its emptiness is extreme even by void standards. The density of matter inside is estimated to be only 10% of the average density of the universe. What if I told you that the implications of this go far beyond just an interesting cosmic feature? The existence of supervoids like boats challenges our understanding of how structure formation works in the universe. According to simulations based on our best theories of gravity and dark matter, supervoids this large shouldn't exist. But there it is, undeniable and unexplained. Margaret Geller and John Huckra, who mapped large-scale structures in the 1980s, discovered that voids aren't truly empty. They found that even in normal voids, there's still dark matter present, still gravitational effects, still subtle flows of gas. The cosmic web isn't static. It's dynamic, with matter constantly falling along filaments toward galaxy clusters. Voids should gradually fill in over time as matter flows through them. But the boat's void shows little evidence of this filling in process. It's remained stubbornly empty for billions of years. It's as if something is actively maintaining the emptiness, pushing matter away rather than allowing it to flow inward. This shouldn't be possible under standard gravitational physics. Now we get to the disturbing part. Remember those 60 galaxies inside the void? Recent observations using advanced telescopes and surveys have revealed something completely unexpected about them. In 2007, a team led by J.P. Kuhn used the Very Large Array Radio Telescope to map the hydrogen gas distribution in the boat's void. Hydrogen is the most common element in the universe, the building block of stars and galaxies. They expected to find traces of hydrogen scattered throughout the void, perhaps explaining why galaxy formation was suppressed there. What they found instead was baffling. The hydrogen distribution didn't match theoretical predictions at all. There were regions where hydrogen should be abundant, but wasn't, and regions where hydrogen appeared in unexpected concentrations. The pattern suggested that something had disturbed the normal process of cosmic evolution in this region. But here's what really shook the astronomical community. In 2015, Andris Kovacs and his team published findings about a strange feature in the cosmic microwave background radiation when viewed through the Boat's void. The cosmic microwave background is the afterglow of the Big Bang, the oldest light in the universe, dating back to when the universe was only 380,000 years old. When this ancient light passes through a void, it should be slightly colder than average due to something called the integrated Sachs-Wolf effect. Think of it like this. As light climbs out of a gravitational well, it loses energy and becomes redder and cooler. Voids are essentially negative gravitational wells, so light passing through them should cool down as the void expands. The Boat's void showed this effect, but it was stronger than it should be. The temperature difference was too large to explain with standard physics. It was as if the void was deeper, emptier, or expanding faster than it should be. This suggested that either our understanding of gravity was incomplete, or something else was influencing the expansion of this region. Then came the real bombshell. Recent galaxy surveys using the Sloan Digital Sky Survey and other instruments found that the galaxies inside the Boat's void aren't just unusual, they're moving in coordinated patterns. Several of the galaxies show peculiar velocities, meaning they're moving in directions that don't match the general expansion of the universe. Here's where your mind should start bending. In cosmology, we expect galaxies to move primarily due to the expansion of space itself, with smaller motions caused by gravitational attraction to nearby structures. But the galaxies in the Boat's void are showing motion patterns that suggest they're being influenced by mass that we cannot detect. Not just dark matter, which we expect to be there, but something else, something creating gravitational effects without any corresponding visible or dark matter signature. What if I told you that some astrophysicists now believe the Boat's void might contain negative mass? I know that sounds like science fiction, but stay with me. In Einstein's equations of general relativity, negative mass is mathematically possible. It would create repulsive gravity, pushing matter away rather than pulling it together. If negative mass exists anywhere in the universe, a supervoid would be exactly where you'd expect to find its effects. This is speculative, cutting-edge stuff, and most scientists remain skeptical. But the fact that serious researchers are even considering such exotic explanations tells you how deeply troubling the observations have become. Let's zoom out for a moment and look at where the Boat's void sits in relation to us. This is where things get really strange, and where some researchers start using words like a coincidence with deeply skeptical tones. The Boat's void is located roughly 700 million light-years from Earth. In cosmic terms, that's relatively nearby. We're not in it, thank goodness, but we're close enough to see it clearly and study it in detail. And here's the thing. We're positioned almost perfectly to see it from the side, to observe its full three-dimensional structure. Now you might think, so what? We happen to be near a big void. The universe is huge. That could just be chance. But here's where it gets weird. The Boat's void is aligned in a very specific way relative to other large-scale structures in the universe. It sits adjacent to massive galaxy superclusters, like a dark counterpoint to the brightest regions of the cosmic web. Sean Thomas and his colleagues published research in 2011, examining what they called void alignments. They found that large voids, including Boats, tend to be aligned with the cosmic microwave background's temperature fluctuations in ways that shouldn't happen if the universe is truly isotropic, meaning the same in all directions. Think of it like this. Imagine you throw a handful of rice in the air and it lands in a perfect pattern spelling out a word. That would be suspicious, right? It would suggest some organizing principle rather than pure randomness. The alignment of supervoids with ancient cosmic structures hints at something similar. Some organizing principle we don't yet understand operating on the largest scales of spacetime. But wait, there's more. The boat's void isn't alone. Astronomers have discovered other supervoids, like the giant void in Cain's Venatici and the Erignus supervoid. Each one presents similar mysteries, similar violations of our expectations. And here's the truly disturbing part. These supervoids seem to be arranged in a pattern, a vast structure of alternating voids and galaxy concentrations that extends across billions of light years. In 2016, our Brent Tully identified what he called the Laniakea supercluster, a galactic superstructure containing our Milky Way and 100,000 other galaxies. This supercluster is being pulled by gravitational attractors, and voids play a crucial role in shaping these flows. The boat's void acts like a gravitational repeller, a region that matter avoids. Now here's what should make you pause. If these voids are arranged in patterns, if they're aligned with ancient cosmic structures, if they're affecting the motion of matter on the largest scales, then they might be telling us something fundamental about the initial conditions of the universe. They might be fossil evidence of whatever process created the Big Bang itself. Some cosmologists, including Lavra Mersini-Houghton, have proposed that these large-scale structures might be evidence of quantum entanglement on cosmic scales, or even evidence of other universes in a multiverse, impressing their gravitational influence on our reality. These are controversial ideas, far from proven, but the fact that mainstream scientists are seriously discussing them shows how inadequate our current theories are for explaining what we observe. Before we go deeper down this rabbit hole, let me ask you something. Are you starting to feel that slight vertigo? That sense that reality is stranger than you thought? Good. That means you're really understanding this. We're about to go even deeper. But first, if you're enjoying this journey into cosmic mysteries, make sure you're subscribed. Smash that notification bell, because we're posting more content that will bend your perception of reality. And if you've made it this far, drop the word void in the comments so I know you're still with me on this journey. Let's talk about what the boat's void tells us about dark matter, because this is where our understanding of the universe starts to completely unravel. Dark matter is one of the most important concepts in modern cosmology. We can't see it, can't detect it directly, but we know it exists because of its gravitational effects. Galaxies rotate too fast to be held together by visible matter alone. Galaxy clusters contain more mass than we can account for by adding up all their stars and gas. The cosmic microwave background patterns require dark matter to explain. About 85% of all matter in the universe is dark matter. Vera Rubin proved the existence of dark matter in the 1970s through her groundbreaking work on galaxy rotation curves. Since then, dark matter has become the foundation of our cosmological models. We've mapped its distribution across the universe, simulated its behavior, and used it to successfully predict many observable features of cosmic structure. But here's the problem. Dark matter should prevent supervoids from existing. According to our simulations, dark matter fills the universe in a relatively smooth distribution, with concentrations in galaxy clusters and filaments, but still present everywhere. Even in voids, there should be substantial amounts of dark matter creating gravitational effects. This dark matter should gradually pull ordinary matter into voids over time, slowly filling them in. Over billions of years, voids should shrink and eventually disappear as structure formation continues. The boat's void isn't shrinking. If anything, some observations suggest it might be growing. The galaxies at its edges aren't falling inward. They're moving away, as if repelled by the void's interior. This is completely backwards from what gravity should do. Think of it like this. Imagine you dig a hole in the ground. Gravity will cause dirt to slide down the edges, gradually filling in the hole over time. But the boat's void is like a hole that keeps getting deeper and wider, with dirt actively moving away from it. That defies everything we know about how gravity works. Pavel Krupa and his colleagues have argued that observations like the boat's void are evidence that our dark matter models are fundamentally flawed. They point out that dark matter has become a catch-all explanation for any observation that doesn't fit our theories. The more we learn, the more complex our dark matter models become, with researchers proposing different types of dark matter, different interaction properties, different distributions. What if I told you that there's an alternative explanation that some physicists are taking seriously? It's called modified Newtonian dynamics, or MOND, proposed by Mordechai Milgram in 1983. MOND suggests that gravity itself behaves differently, on the largest scales than Einstein's general relativity predicts. Instead of invoking dark matter, MOND argues that we need to modify our understanding of gravity itself. MOND successfully explains galaxy rotation curves without dark matter. It predicts some large-scale structures that match observations. But it struggles with other observations, particularly the cosmic microwave background and galaxy cluster collisions. Most physicists consider MOND insufficient to replace dark matter entirely. However, the boat's void presents a challenge for both dark matter and MOND. Neither theory adequately explains its existence, its size, or its persistence. Some researchers are now proposing hybrid theories that combine aspects of dark matter and modified gravity, suggesting that reality might be even stranger than either approach alone suggests. Here's what keeps me up at night about this. What if both approaches are wrong? What if dark matter exists, but isn't what we think it is? What if gravity does work differently on large scales, but not in the way MOND proposes? What if the boat's void is showing us a third option, something we haven't even imagined yet? Eric Verlinde proposed in 2016 that gravity itself might be an emergent phenomenon, arising from the quantum entanglement of spacetime itself, rather than being a fundamental force. In his model, what we call dark matter might actually be an effect of how information is distributed throughout space. The boat's void, in this framework, would represent a region where spacetime is structured differently, where the emergent gravity behaves anomalously. These ideas remain highly speculative and controversial, but they illustrate how deeply the existence of structures like the boat's void challenges our fundamental understanding of physics. Now we need to talk about dark energy and the expansion of the universe, because the boat's void has something shocking to teach us about this too. In 1998, two teams of astronomers, led by Saul Perlmutter and Brian Schmidt, discovered that the universe's expansion is accelerating. This shouldn't happen. After the Big Bang, the expansion should be slowing down due to gravity, like a ball thrown upward, gradually decelerating. But observations of distant supernova prove that the expansion is speeding up instead. This discovery won the Nobel Prize and revolutionized cosmology. Scientists proposed that an unknown force, dubbed dark energy, is pushing space apart, overwhelming gravity on the largest scales. Dark energy now makes up about 68% of the total energy content of the universe. It's the dominant force shaping cosmic evolution. But here's the thing. We have no idea what dark energy actually is. We can measure its effects, we can quantify how strongly it pushes, but we don't know its fundamental nature. Is it a property of space itself? Is it a quantum field permeating the universe? Is it something even stranger? The boat's void might hold a clue. When Kovacs studied the cosmic microwave background signal through the void, he found something unexpected. The void seems to be expanding faster than the surrounding universe. It's as if dark energy is stronger inside the void, accelerating its growth beyond what we'd normally expect. This makes no sense in our standard model. Dark energy is supposed to be uniform throughout space, pushing equally everywhere. It shouldn't concentrate in certain regions or be stronger in some places than others. But the observations suggest otherwise. Some cosmologists have proposed that dark energy might not be uniform after all. Maybe it has structure, variations in strength across the universe. Maybe voids are regions where dark energy is anomalously strong, explaining both their existence and their persistence. But this creates a host of new problems. If dark energy varies, what determines its variations? What force or field could modulate its strength? Here's where things get truly mind-bending. Sean Carroll and others have pointed out that dark energy's strength appears to be fine-tuned to an almost impossible degree. If dark energy were slightly stronger, it would have prevented galaxies from forming at all, ripping apart any structure before gravity could bring matter together. If it were slightly weaker, it might not be noticeable at all. The fact that dark energy is just strong enough to dominate the universe now, billions of years after the Big Bang, seems like a remarkable coincidence. The boat's void, with its apparent variations in dark energy strength, might be showing us that this fine-tuning isn't uniform across space. Maybe there are regions where dark energy is stronger and regions where it's weaker. Maybe what we measure as the cosmic average is just that, an average with significant local variations. Think about what this means. If dark energy varies across space, then the universe's future isn't uniform. Some regions might expand faster than others. The cosmic web might eventually fragment, with galaxy clusters becoming isolated islands in an ocean of accelerating void space. Billions of years from now, galaxies in different regions might lose contact with each other entirely, as the space between them expands too rapidly for light to cross. But here's an even more disturbing possibility. What if the boat's void is a glimpse of the universe's future? What if, as dark energy continues to dominate, more and more of space will become like the void, empty and expanding ever faster? What if the structures we see, the galaxies and clusters, are temporary islands of matter that will eventually be overwhelmed by the void? This scenario is called the Big Rip, one possible ultimate fate of the universe. If dark energy continues to strengthen over time, it will eventually become so powerful that it tears apart galaxies, then solar systems, then planets, then atoms themselves. Everything will be ripped to shreds by the accelerating expansion of space. The boat's void might be showing us the first stages of this process. Let's step into even stranger territory. What if the boat's void is evidence that we're living in a simulation? I know. This sounds like we've left science behind and entered pure speculation. But hear me out, because there are serious physicists and cosmologists considering this possibility, and the boat's void factors into their reasoning. The simulation hypothesis was popularized by philosopher Nick Bostrom in 2003, though scientists and philosophers have explored similar ideas for decades. The basic argument goes like this. If it's possible to create realistic simulations of conscious beings and their environment, and if civilizations typically create many such simulations, once they become technologically advanced, then statistically speaking, we're more likely to be in a simulation than in base reality. Now, how does the boat's void connect to this? Well, if we are in a simulation, that simulation has to run on some form of computing substrate, and that means it has resource limits. Even an incredibly advanced civilization would face constraints on how much detail they could simulate simultaneously. Think of it like a video game. To save computing power, game designers use tricks like level of detail scaling. They render distant objects in less detail than nearby ones. They use procedural generation to create vast environments without storing every detail explicitly. And sometimes they leave regions intentionally sparse or empty to save resources. What if cosmic voids are the universe's way of conserving computational resources? In regions where nothing important is happening, where there are no observers, the simulation could run in a simplified mode, generating only minimal detail. The few galaxies in the boat's void might be placeholder objects, sufficient to maintain consistency but not fully detailed. James Gates Jr., a theoretical physicist at the University of Maryland, discovered something remarkable while studying string theory and supersymmetry. Buried in the equations that describe fundamental particles and forces, he found what appear to be error-correcting codes, mathematical structures identical to those used in computer systems to detect and fix data corruption. Now, Gates himself doesn't claim this proves we're in a simulation. The codes might be a coincidence, or they might reflect something deep about information theory and physics. But their presence is undeniably intriguing. If the universe is fundamentally computational in nature, whether or not it's a deliberate simulation, then features like error-correcting codes and resource optimization would be expected. The Boat's void's unusual properties, its strange effect on the cosmic microwave background, the coordinated motion of its few galaxies, could all be artifacts of simplified simulation in a low-priority region. When we observe the void carefully, bringing our attention to it, the simulation might need to generate more detail to maintain consistency, creating the anomalies we detect. This sounds crazy, but here's what's not crazy: the fundamental idea that information is the basis of physical reality. This concept, sometimes called it from bit, after physicist John Wheeler's famous phrase, is increasingly mainstream in theoretical physics. Quantum mechanics tells us that physical properties don't have definite values until they're measured, which suggests that observation and information play a fundamental role in determining reality. What if I told you that the very idea of empty space is problematic in quantum mechanics? According to quantum field theory, even the vacuum of space isn't truly empty. It's filled with quantum fluctuations, virtual particles popping in and out of existence, energy fields permeating every point. The vacuum has structure and properties. But in the Boat's void, the vacuum seems to behave differently. The quantum fluctuations might be different. The vacuum energy might be unusual. This could be because the void represents a region where the underlying computational substrate of reality is operating in a different mode. Whether or not we're in a simulation, the Boat's void is telling us something profound about the nature of space itself. It's not just empty volume. It's a physical thing with properties and behaviors that can vary from place to place. Here's where we need to make this personal. Let's talk about why the Boat's void matters to you, to your existence, to consciousness itself. The anthropic principle, developed by Brandon Carter in 1973, observes that the universe's properties seem remarkably fine-tuned for the existence of life and consciousness. The strength of gravity, the mass of the electron, the rate of cosmic expansion. Dozens of fundamental constants all fall within narrow ranges that allow complex structures like stars, planets, and living beings to exist. Change any of these constants by even a tiny amount, and the universe becomes hostile to life. Stronger gravity would cause stars to burn out too quickly. Weaker electromagnetic force would prevent chemical bonds from forming. Slightly more dark energy would have prevented galaxies from forming at all. The traditional explanation is the weak anthropic principle. We observe these values because we exist to observe them. In universes with different constants, no observers would evolve to ask questions. It's a selection effect, not a mystery. But the strong anthropic principle suggests something more. Perhaps the universe's properties are not random, but are somehow necessary for consciousness to exist. Maybe consciousness plays a role in determining the structure of reality itself. The Boat's void fits into this in a disturbing way. Remember how I said its properties seem to violate our standard models? Well, here's something fascinating. The void's existence might actually be necessary for our galaxy to be where it is, with the properties it has. The cosmic web structure, including voids like Boats, determines the large-scale gravitational flows that shaped our local galactic environment. The Milky Way sits in the Laniakea supercluster, and the positioning of nearby voids influenced how matter flowed to create our galaxy. If the Boat's void didn't exist or had different properties, the gravitational landscape would be different, and our galaxy might never have formed, or might have formed differently. Think about the chain of causation here. The quantum fluctuations in the first moments after the Big Bang led to slight density variations. Those variations were amplified by gravity over billions of years, creating the cosmic web. The cosmic web structure, including supervoids, determined where galaxies formed. The location and properties of our galaxy determined where and when our solar system formed. And the solar system's properties determined whether Earth could develop life and eventually conscious observers like you and me. The boat's void is part of the causal chain that led to your existence. Without it, you wouldn't be here reading this script. Now, here's where it gets really weird. Quantum mechanics tells us that observation affects reality. The famous double-slit experiment shows that particles behave differently when observed versus when unobserved. Some interpretations of quantum mechanics, particularly the participatory anthropic principle proposed by John Wheeler, suggest that observers play an active role in bringing the universe into existence. In this view, the universe exists in a superposition of possible states until consciousness observes it and collapses those possibilities. This would explain several of its anomalous features. The unusual dark energy strength could reflect different vacuum properties from another universe bleeding through. The deficit of galaxies could result from matter flowing or being influenced by gravitational effects from another universe. The strange alignments with ancient cosmic structures could reflect the initial conditions where universes touched or separated in the earliest moments of time. Max Tegmark has categorized different types of multiverses from level 1, simply different regions of our own infinite space, to level 4, where all mathematically possible structures exist as separate realities. The boat's void might provide evidence for level 2 multiverse, the eternal inflation scenario, where different bubble universes exist within a larger inflating space. But here's what really bends the mind. If the multiverse exists, then everything that can happen does happen somewhere. Every possible variation of physical laws, every possible history, every possible version of you exists in some universe within the multiverse. There are universes where the boat's void doesn't exist, universes where it's even larger or smaller, universes where voids dominate and galaxies are rare exceptions, universes where Earth never formed, where life never arose, where you never existed. And crucially, there are universes where observers are asking the same questions we're asking, looking at their own cosmic anomalies, wondering about the nature of reality. The anthropic principle takes on new meaning in the multiverse context. We don't observe a finely tuned universe because the universe is special. We observe it because we can only exist in universes with these properties. The multiverse generates all possibilities, and we necessarily find ourselves in one of the rare universes where observation is possible. The boat's void, in this context, is a reminder of how special and improbable our existence is. It's a glimpse of what most of reality might look like: empty, dark, devoid of structure or complexity or life. We exist in a rare island of complexity in an ocean of void. But here's what gives me chills. If the multiverse exists, and if consciousness plays a role in collapsing quantum possibilities into definite reality as some interpretations suggest, then every conscious being is in some sense creating their own branch of reality through observation. You're not just observing the universe. You're participating in selecting which branch of the multiverse you inhabit through the act of observation itself. Every time you observe something, every time you make a measurement or decision, you're navigating through the landscape of possible realities, choosing a path through the infinite garden of forking paths. The boat's void exists in your branch of reality because you're observing it right now. In other branches, other versions of you might be looking at different cosmic anomalies, or not looking at all. Now let's talk about something that connects the boat's void to black holes, quantum mechanics, and the fundamental nature of information itself. This is where physics gets truly bizarre. Stephen Hawking discovered in 1974 that black holes aren't completely black. They emit radiation due to quantum effects near their event horizons, slowly evaporating over time. This created a massive problem called the black hole information paradox. Here's the issue. When matter falls into a black hole, it carries information, its quantum state, its properties, its history. When the black hole eventually evaporates through Hawking radiation, where does that information go? If it's destroyed, that violates quantum mechanics, which says information is never truly lost. If it's preserved, we need to explain how information that fell past the event horizon can escape, which violates general relativity. This paradox has consumed some of the brightest minds in physics for 50 years. Leonard Susskind, Gerard 't Hooft, and others proposed that information is actually encoded on the surface of the event horizon, like a hologram. This led to the holographic principle, the idea that all the information in a volume of space can be encoded on its boundary surface. Now here's where the boat's void enters the picture in a shocking way. What if voids function similarly to the interiors of black holes, but in reverse? Black holes are regions where gravity is so strong that nothing can escape. Voids are regions where matter is so sparse that gravity is anomalously weak, where dark energy's repulsive effect dominates completely. Juan Maldaceni's ADCCFT correspondence, one of the most important developments in theoretical physics, proved that for certain types of spacetime, all the physics happening in a volume of space can be completely described by a theory operating on the boundary of that space. The interior physics is holographically encoded on the surface. What if this principle applies to cosmic voids? What if all the information about what happened inside the boat's void over billions of years is encoded holographically on its boundary, in the shell of galaxies and matter at its edges? This would explain some of the void's strange properties. The unusual motion of galaxies at the void's edge, the peculiar effects on the cosmic microwave background, the coordinated patterns we observe, these could all be manifestations of holographic information encoding. The void's interior might be simpler than it appears, with most of the complex physics actually happening as information processing on its boundary. Think of it like this. When you watch a 3D movie, all the depth information is actually encoded in a flat 2D screen. Your brain reconstructs the three-dimensional scene from the two-dimensional information. The holographic principle suggests something similar about space itself. What we perceive as three-dimensional space with depth and volume might actually be a reconstruction of information encoded on a two-dimensional surface. If the boat's void operates holographically, then its interior might not be real in the way we normally think about space. The 330 million light-years of emptiness might be more like the interior of a 3D movie, an illusion created by information processing on the void's boundary. This connects back to the simulation hypothesis in a profound way. If reality is fundamentally informational and holographic, then the distinction between base reality and simulation becomes meaningless. Both would be information structures, just operating at different levels. But here's what keeps physicists awake at night. The holographic principle implies that the universe has a finite information capacity. The amount of information that can exist in any region of space is limited by the surface area of that region's boundary, not its volume. This is like saying a library can only hold as many books as can fit on its walls, not on its shelves. For the observable universe, this maximum information capacity is about 10 to the power of 120 bits, an incomprehensibly large but ultimately finite number. Every particle, every field, every quantum state in the entire observable universe represents a portion of this information budget. The boat's void, being mostly empty, represents very little information. It's like a blank page in the universe's information structure. But that blank page still needs to exist within the holographic framework. The void isn't nothing. It's the information structure that represents nothing, which is itself something. What if I told you that some physicists believe the universe might be reaching its information capacity? As structure formation continues, as complexity increases. As conscious observers multiply throughout the cosmos, the information content of the universe grows. If there's a hard limit, what happens when we reach it? Maybe voids like boats are the universe's way of managing its information budget. By keeping vast regions simple and empty, the universe can support complex structures like galaxies, stars, planets, and life in other regions. The voids are necessary simplicity that allows for complexity elsewhere. You might be thinking this is all absurdly abstract. But here's why it matters personally. You are an information structure. Your consciousness, your memories, your thoughts, everything that makes you you, is ultimately patterns of information encoded in the physical structure of your brain. If the universe has an information budget, and if that budget is finite, then every conscious being represents a significant allocation of that cosmic information capacity. You're not just matter and energy. You're a complex, highly organized information structure that the universe has invested enormous resources in creating. The fact that you exist, that you're conscious and observing and thinking about cosmic voids, means the universe has allocated part of its precious information capacity to your existence. That's not mysticism. That's physics. Let's connect the boat's void to another mysterious cosmic structure, the Great Attractor. This is where we start to see how all these strange features fit together into a larger, even more disturbing pattern. In 1986, a team of astronomers led by Donald Lynden Bell discovered something shocking. Our galaxy, along with thousands of others in our cosmic neighborhood, is moving at about 600 kilometers per second toward a point in space. This isn't just the expansion of the universe. This is motion through space, a cosmic river flowing towards something massive. They called it the Great Attractor, a gravitational anomaly located about 150 million light-years away in the direction of the Hydra and Centaurus constellations. It's partially hidden behind the disk of our own Milky Way, making it difficult to observe directly. But its gravitational influence is undeniable. Here's where it gets weird. The Great Attractor isn't massive enough to explain the motion we observe. Even accounting for all the visible galaxies and estimated dark matter in that region, there's not enough mass to pull thousands of galaxies at such high speeds. Something else must be going on. Later observations revealed an even larger structure, the Shapley supercluster, lying beyond the Great Attractor. And beyond that, other massive structures create an enormous gravitational landscape, shaping the motion of galaxies across hundreds of millions of light years. But voids like boats play a crucial role in this cosmic choreography. They're not just empty space. They're gravitational repellers. While massive structures pull galaxies toward them, voids push galaxies away. The motion of galaxies throughout the universe results from the combined pull of attractors and push of voids. Think of it like a landscape of hills and valleys. Water flows downhill and away from the hilltops. Similarly, galaxies flow toward massive structures and away from voids. The cosmic web is shaped by this dynamic balance between attraction and repulsion. But here's what disturbs cosmologists. The pattern of motion doesn't quite match our predictions. Yehuda Hoffman and his team created detailed maps of cosmic flows and found discrepancies between observed motions and what our models predict based on the known distribution of matter. It's as if there are hidden masses or hidden voids that we can't directly observe, but whose gravitational effects are shaping galactic motion. The boat's void might be part of a larger pattern of hidden structures operating on scales we're just beginning to comprehend. Here's where your mind should really start bending. What if the entire observable universe is itself inside a much larger structure, a supervoid in an even larger cosmic web? Some cosmologists have proposed that many of the anomalies we observe in the cosmic microwave background and large-scale structure could be explained if our observable universe sits in a void region of a much larger cosmos. This would mean that everything we can see, all 93 billion light-years of observable universe, represents a biased sample. We're looking at reality from inside a bubble. And what we perceive as the universal laws of physics might actually be local conditions that vary in other regions beyond our observational reach. Timothy Clifton and Pedro Ferreira explored this idea in 2009, showing that if we're inside a large void, it could explain the apparent acceleration of cosmic expansion without needing dark energy at all. The acceleration might be an illusion created by observing from within an underdense region. This remains controversial, and most cosmologists think we're not in a special void location. But the fact that this idea can even be seriously proposed shows how uncertain we are about our place in the cosmos. The boat's void might be showing us, on a smaller scale, what our own larger cosmic environment looks like from the outside. We might be the sparse galaxies inside a supervoid, wondering why things look the way they do, not realizing we're in an anomalous region of a much larger structure. Now here's something that should make you pause and reflect. The cosmic flows. The motion of galaxies through space means that everything is moving relative to everything else on cosmic scales. Your position in space isn't fixed. The Earth orbits the Sun orbits the galactic center, the Milky Way moves through the local group moves through Laniakea, and Laniakea flows through even larger structures. You are traveling through space at hundreds of kilometers per second right now, pulled by the Great Attractor and pushed by the boat's void and other cosmic structures. Your cosmic address is constantly changing. The only reason you don't feel it is that everything in your local environment is moving together. But think about what this means for the nature of location and identity. Where are you, really? What does it mean to be here when here is a moving point in a flowing cosmic river? Your location in space-time is unique, a position in the four-dimensional fabric of reality that will never be occupied again once this moment passes. We're approaching the end of our journey, but before we get there, we need to confront something truly disturbing about the boat's void and what it tells us about the ultimate fate of the universe. Remember how I mentioned that dark energy is causing the expansion of the universe to accelerate? This has profound implications for the distant future. As space expands faster and faster, distant galaxies will recede from us at ever-increasing speeds. Eventually, they'll cross what's called the cosmic event horizon, the distance beyond which objects recede faster than the speed of light. Once something crosses our cosmic event horizon, we can never see it again, never communicate with it, never interact with it in any way. It's permanently beyond our reach, removed from our observable universe forever. Right now, our observable universe is about 93 billion light-years in diameter. This is larger than you might expect given the universe's age of 13.8 billion years, because space itself has been expanding. But as dark energy continues to drive accelerating expansion, our observable universe will actually shrink over time. Lawrence Krauss and Robert Scherer calculated in 2007 that in about 100 billion years, every galaxy beyond our local group will have crossed our cosmic event horizon. An observer in that distant future would see a universe containing only the merged remnants of the Milky Way and Andromeda galaxies, surrounded by darkness. The cosmic microwave background would fade to undetectability. All evidence of the Big Bang, of cosmic expansion, of the vast universe beyond, would disappear. Those future observers couldn't discover cosmology as we know it. They'd have no way to learn about the true scale and history of the cosmos. They'd be cosmically lonely, trapped in an island of matter with no evidence of the larger structure they're part of. But here's the truly disturbing part. The boat's void is a preview of this future. It's a region where galaxies are isolated, where cosmic structure has been erased, where the evidence of a larger universe is minimal. The few galaxies inside the void are already experiencing a version of what all galaxies will eventually experience: cosmic loneliness in an expanding emptiness. And it gets worse. If dark energy continues to strengthen, as some models suggest it might, the acceleration will become so extreme that it will eventually tear apart gravitationally bound structures. First, galaxy clusters will dissolve, then galaxies themselves, then solar systems, then planets, then molecules, then atoms, and finally, even atomic nuclei and subatomic particles. This is the Big Rip scenario I mentioned earlier. In this future, the universe doesn't end in cold darkness, but in a catastrophic fragmentation where everything is torn to pieces by the exponentially accelerating expansion of space. Current estimates suggest this could happen in about 22 billion years if dark energy behaves in certain ways. The Boat's void might be showing us the early stages of this process, a region where the fabric of space is already stretching more aggressively than elsewhere, where the structure-building force of gravity has been overwhelmed by the structure-destroying force of dark energy. Think about what this means. Right now, in this moment, we exist in what might be a brief golden age of cosmic structure. The universe is old enough that complex structures have formed, stars and planets and life, but young enough that everything hasn't been ripped apart by accelerating expansion yet. We exist in a narrow window of cosmic time where observation and understanding are possible. Future civilizations, if any exist, won't have the privilege we have. They won't be able to see the cosmic web, the distribution of galaxies, the evidence of how the universe evolved. Past civilizations, if any existed, wouldn't have had stars and planets yet. We're here at just the right time to understand our cosmic context. Some cosmologists speculate about vacuum decay, the possibility that our current vacuum state isn't the lowest energy state possible. If that's true, a bubble of new vacuum could spontaneously form somewhere in the universe and expand at the speed of light, transforming the physics of everything it touches. Inside the bubble, fundamental constants would be different. Particles would have different properties, and entirely new forms of structure might be possible. Voids like boats, with their unusual properties and strange behavior, might be more likely sites for such phase transitions. The emptiness might make them cosmically unstable, susceptible to vacuum decay that could create pocket universes with new physics. This is speculative, but it illustrates an important point. The universe is still surprising us. Every time we think we understand the rules, we discover something that doesn't fit. The Boat's void is just the latest in a long line of cosmic mysteries that have forced us to expand our understanding of reality. We've journeyed through 330 million light-years of emptiness and discovered that it's full of mysteries. Now, in these final moments, I want to bring this back to you, to why this matters personally, to how understanding the Boat's void changes your relationship with existence itself. Here's what we've learned. The universe is stranger than we imagined. The Boat's void shouldn't exist according to our theories, yet it does. It's too large, too empty, and too persistent. It shows signs of unusual dark energy strength, strange gravitational effects, and possible connections to the deepest questions in physics about dark matter, cosmic structure formation, and the nature of space itself. We've seen how it might connect to the multiverse, to quantum mechanics, to consciousness, and to information theory. We've explored how it fits into cosmic flows and large-scale structures. We've contemplated its implications for the universe's ultimate fate and our own place in the cosmic story. But what does this mean for you, personally? Why should you care about an incomprehensibly large, empty region of space, hundreds of millions of light-years away? First, the Boat's void is a reminder of how much we don't know. We live in an age where it's easy to feel like science has figured everything out, like we understand reality, and the universe is just details left to fill in. The void tells us that's not true. We're still at the beginning of understanding. The universe still holds profound mysteries that challenge our most fundamental assumptions. This should be liberating. You live in a cosmos that is still mysterious, still surprising, still full of wonder. The questions you ask matter because we don't have all the answers yet. Your curiosity about the universe isn't trivial. It's participating in humanity's ongoing quest to understand our context and our place in reality. Second, the void reminds us of how special structure and complexity are. Most of the universe is empty space. The cosmic voids, even though they represent the largest structures we know of, contain almost nothing. Matter, stars, planets, life, consciousness, these are rare exceptions, precious islands of complexity in an ocean of void. You are made of matter that has been through multiple generations of stars. The carbon in your body, the oxygen you breathe, the calcium in your bones, all of it was forged in stellar furnaces billions of years ago. That matter came together through incredibly unlikely cosmic accidents to form a planet in the habitable zone of a stable star, and then through further accidents developed life, consciousness, and eventually you. The probability of your existence is vanishingly small. If any of countless cosmic parameters were slightly different, if the distribution of matter in the early universe had varied by tiny amounts, if the Boat's void or structures like it didn't exist to shape the cosmic web in just the right way, you wouldn't be here. But you are here. Against all odds, the universe has arranged itself in such a way that you exist and can contemplate your own existence. That's not a religious statement. It's simple fact. The universe has been working for 13.8 billion years to create the conditions for your existence. And now you're here, conscious and aware. Third, the void teaches us about perspective. When you look up at the night sky, you're seeing stars in our galaxy, a tiny corner of the observable universe. The scale beyond that is almost impossible to grasp. The Boat's void is so large that our entire galaxy could traverse it for hundreds of millions of years at the speed of light and still be inside emptiness. Yet despite this incomprehensible scale, despite the vast gulfs of space and time, you matter. Not because you're significant compared to the universe, you're not, but because significance doesn't work that way. Consciousness doesn't need to be large to be important. Your subjective experience, your awareness, your thoughts and feelings, these have value not despite their tiny scale, but because of their very existence. The universe has created in you a way to know itself. Through your eyes, the cosmos observes its own structure. Through your thoughts, the universe contemplates its own nature. You are the universe becoming self-aware, locally and temporarily, but genuinely. Fourth, the mysteries of the void remind us to stay humble and curious. Every generation thinks it's close to understanding everything, and every generation discovers how wrong that assumption was. The physicists of the 1890s thought they'd nearly completed physics, needing only to measure a few more decimal places. Then came relativity and quantum mechanics, completely revolutionizing our understanding. Today's cosmologists have built beautiful models of cosmic evolution, but structures like the Boat's void show us those models are incomplete. We're missing something fundamental, whether it's about dark matter, dark energy, gravity itself, or something we haven't even conceived of yet. What mysteries will future generations uncover? What fundamental assumptions are we making that will seem as quaint and limited as medieval cosmology seems to us now? We can't know, but we can maintain the intellectual humility to recognize that our understanding is provisional, always open to revision when new evidence emerges. This applies to your personal life too. Stay curious, question assumptions. Remain open to having your worldview challenged and expanded. The universe is teaching us, through structures like the Boat's void, that reality is always more complex and more interesting than our theories about it. Fifth, the void speaks to the value of emptiness and silence. In our connected, information-saturated world, we've lost appreciation for empty space, for quiet, for absence. Everything must be filled, every moment documented, every silence uncomfortable. But the Boat's void shows us that emptiness has structure and meaning. The void isn't nothing. It's a dynamic region of space with properties and effects. Sometimes absence is as important as presence. Sometimes empty space allows other things to exist and flourish. In your own life, create voids. Make space for quiet contemplation, for unstructured time, for the possibility of unexpected thoughts and feelings to emerge. Don't fill every moment. Like the cosmic web needs voids to allow galaxies to form along filaments, you need empty space in your life to allow meaningful experiences and insights to emerge. Now let me share something that might change how you see yourself. We've talked about how the universe might be holographic, how information might be more fundamental than matter, how consciousness might play a role in determining reality. If any of this is true, then you're not just made of atoms arranged in interesting patterns. You're an information structure, a pattern of such complexity and coherence that it has become self-aware. Your consciousness is perhaps the most remarkable structure in the known universe. It's more complex than any star, any galaxy, any void. The patterns of neural connections in your brain, the electrochemical signals flowing through them, the emergent phenomenon of subjective awareness arising from this biological computer, this is cosmically significant. The universe spent billions of years evolving from simple hydrogen gas after the Big Bang, to stars that forged heavier elements, to planets where those elements could combine in ever more complex ways, to chemistry that became biology, to biology that became neurology, to brains that became conscious. You are the universe's greatest achievement so far, at least that we know of. And the boat's void, in its own strange way, contributed to creating the conditions that allowed your existence. The cosmic web shaped by voids and structures determined where and how galaxies formed, which influenced where stars like our sun could form, which made possible the existence of planets like Earth, which allowed for the emergence of life and consciousness. Everything is connected across space and time in ways we're only beginning to understand. The void isn't separate from you. It's part of the cosmic context that made you possible. As we close, I want you to try something. Tonight, if the sky is clear, go outside and look up. Find the constellation Boats. It's visible from most of Earth during spring and summer in the northern hemisphere, or autumn and winter in the southern hemisphere. Look for the bright star Arcturus, one of the brightest in the sky, and the constellation around it. Know that beyond what you can see, in that direction, lies a void of incomprehensible scale and mystery. Light that left that region 700 million years ago is just now reaching your eyes. When that light began its journey, complex life was just emerging on Earth. Multicellular organisms were first evolving. The continents were arranged differently. Nothing like human consciousness existed yet, but the light traveled across the void, across the cosmic web, across the vast gulfs of space, for 700 million years to arrive at this moment and enter your eye. That light carries information about the structure of space-time, about the distribution of matter, about cosmic evolution. And you, a conscious being made of matter created in stars, are now aware of that light, that void, that history. This moment connects you to the largest structures in the cosmos. You are part of this cosmic story. The void isn't just something happening out there in space. It's part of the web of causation that led to your existence. It shaped the gravitational landscape that determined how our local cosmic environment evolved. In a very real sense, you exist because the void exists. And here's the final thought I want to leave you with. Despite everything we've learned, despite all the mysteries and anomalies and disturbing implications, the universe is fundamentally comprehensible. We can use mathematics and observation and reason to understand cosmic structures millions and billions of light years away. We can probe the first moments after the Big Bang. We can predict the ultimate fate of the cosmos billions of years in the future. This shouldn't be possible. Why should the universe be structured in a way that conscious beings made of atoms can understand it? Why should mathematics, an invention of human minds, describe the behavior of reality with such precision? Why should the laws of physics remain consistent across billions of light years and billions of years? These are deeper mysteries than the boat's void itself. The fact that we can study the void, measure it, build models of it, argue about what it means, This is perhaps the most profound mystery of all. You have the ability to contemplate structures larger than your imagination can really grasp. You can think about time scales that dwarf human history. You can understand, at least in mathematical terms, the curvature of space-time and the quantum nature of reality. This is extraordinary. The boat's void is disturbing not because it threatens us, it doesn't, but because it shows us how much we don't know and how strange reality is beneath the familiar surface. But that strangeness is also beautiful. It means you live in a universe that's endlessly fascinating, that will never stop surprising us, that rewards curiosity and wonder. So, be curious. Ask questions. Look up at the sky and marvel at the fact that you're part of this cosmic dance. The void is out there, mysterious and strange, but so are you. And in your own way, you're just as mysterious and just as strange. We've covered a lot of ground in these 3 hours, from the discovery of the void to its implications for dark matter, dark energy, the multiverse, consciousness, and the nature of reality itself. We've seen how cutting-edge physics is grappling with observations that don't fit our theories, how scientists like Kirshner, Rubin, Hawking, and countless others have pushed our understanding forward while revealing ever deeper mysteries. The boat's void stands as a testament to how much we've learned and how much remains to be discovered. It's a blank page in the cosmic story, but one that's teaching us to ask better questions about the nature of space, time, matter, and existence itself. Thank you for taking this journey with me into the void and back. If this has sparked your curiosity, if it's changed how you see the universe even slightly, then we've accomplished something meaningful together. We've participated in the universe's ongoing project of understanding itself. Before you go, I want to hear from you. What aspect of this cosmic mystery fascinated you most? Are you more intrigued by the physics, the philosophical implications, or the connection to consciousness and existence? Drop a comment and let me know. And if you found this valuable, share it with someone who you think would appreciate having their mind bent by cosmic mysteries. Subscribe if you haven't already, because we're going to keep exploring the edges of knowledge where science meets philosophy meets wonder. There are more mysteries out there waiting to blow your mind, and I want you along for the journey. Look up tonight. Look toward boats. And remember, you're not just looking at the void. You're part of the cosmic story that created it and that it helped create. You're a way for the universe to know itself, and that's more significant than any void, no matter how large or mysterious. The universe is strange, beautiful, and ultimately comprehensible to minds like yours. Never forget that. And never stop asking questions. Until next time, keep looking up, keep wondering, and keep questioning everything you think you know about reality. The void is waiting, and so are countless other mysteries. This is where our journey ends, but your exploration of the cosmos has just begun.